Earlier in the lesson, we briefly introduced arrays. Here we will give more details. Most importantly, we will look at two alternatives for creating arrays. The easiest and simplest alternative is what I call the one-step process. You declare the array and you give the values inside curly braces separated by commas, all in the same statement. So for example, I can say I want an array of whole numbers int. The variable name is values. And oh, here they are. 10, 100, and 1,000, inside curly braces separated by commas. Or I can say I want an array of strings, variable name names, and oh, here are the values, inside curly braces separated by commas. Or I want an array of points, that's a built-in class in Java, here's the variable name, and oh, here are the values. So in the one-step process, you declare the array, and you give the values inside curly braces separated by commas, all in the same statement. That's the simplest approach, and that's the approach you should always use whenever it applies. However, it doesn't always apply. In particular, the one-step approach that we just looked at here only applies if you know ahead of time how many entries are in the array and what the values are. But frequently, you don't know how big the array is until you do some calculation when the program is running. So then, you need the two-step process. In the two-step process, first you make an array, an empty array of a certain size, and then secondly you fill it in. So for example, I say int array, I make up a variable name, and then I say new, something we haven't seen before, new int and a number. Let's say x is 7, new int 7. That makes space for 7 integers, 7 whole numbers, but it doesn't put anything in it except zeros to begin with. So the array is essentially empty. I have to then go and insert the numbers. Or I could say string array names equals new string, and suppose I supply a variable 13. New string 13. So it makes space for 13 strings, but it doesn't actually put any strings in. If I really want to quibble and be precise, the way to say it is it makes an array containing 13 null string pointers. But the way most people think of it is it makes space for 13 strings, but it doesn't put the strings in. So first I make space, and then I have to put things in it. So suppose I have whole numbers. I have to then insert entries at each of the indices. Now, I listed out the values, separately on separate lines. More likely you'll use a loop. I'll say int array primes equals new int 37, and then I'll have a loop where I loop from 0 to 36 and insert something in. Similarly, if I say string array names equals new string square brackets 13, I have to go from 0 to 12 and insert specific strings in. And again, probably in real life I'll do that inside a loop. But the point is, it's in two steps. First, I allocate space, or I allocate places where you can put the strings or the numbers, and then secondly, I go and put the values in. The next question is, what happens if I don't put the values in? And the answer is, well, it depends on whether they're numbers or they're objects. And strings are objects. So if they're numbers and you don't put anything in, then the default value is 0. So if I say nums equals new int 7, then they're all zeros. So if I look up the third entry and I add 3 to it, well, the third entry is 0 because I haven't put any real numbers in there. So 3 plus 0 is 3. But for objects arrays, like strings, if I don't put anything in, it's null. So if I say new string 7, there aren't 7 real strings. There are 7 null pointers. And so if I print out the third entry, it'll print out the word null. But if I try to call a method on the fourth entry, it'll crash because words sub 3 is null. You can't call contains on null. You can only call contains on a real string. So the point here is that you make space and then you have to separately insert the individual elements. If you forget to insert the individual elements, you're headed for disaster. So let's look at the right way to do it first, and then we'll look at two common wrong ways to do it and explain why they're wrong. So the right way to do it is, let's say I have a class called circle. And circle has a constructor that you can supply a radius to. and we'll actually define this class later on, but that's, I think even though we don't understand exactly how to make classes, we can understand the gist of this. So this line says, make space for this number of circles. Let's say you supply 13. Make space for 13 circles. But there aren't any circles in that array yet. There's just space for 13 circles. So then you loop from 0 to less than 13, in other words, to 12, from 0 to 12. And at each entry, you put in a circle. That's the right way to do it. You allocate space, then you loop down and you insert a circle into each one. Okay, so that's the correct way to do it. But there are two approaches that are wrong, but are very tempting. And so I want to warn you away from them so that you won't fall into this trap when you actually try it. So the next approach is to say, well, suppose in my circle class, I have a method that lets you change the radius. You might be tempted to just make an array and then change all the radii. So you might say this, make an array of circles, then loop from 0 to less than the length, in other words, from 0 to 12 if the size of the array is 13, and change the radius of each one. And you'll think that, oh, that's equivalent to my last one. My last approach, I created circles with a certain radius. Here I took my default circles and I changed the radius. Wrong, because the line at the top here did not actually make any circles. I can't change the radius of null. I can only change the radius of a real circle. So the second approach will crash with a null pointer exception. It'll say you can't call set radius on null. You can only call set radius on a circle, because the line at the top, new circle 13, did not make any circles. The other approach that's tempting is to use the for each loop that we just looked at a couple of subsections ago with the colon. So you say, all right, let's make an array that can hold 13 circles. And yes, I understand there's not any circles in it yet. I want to put circles in it. So I'll say for each circle C in circles, redefine C to be an actual circle object. Good idea, but still wrong. And the reason that it's wrong is that you assigned a circle object to C, but you didn't put it back into the array. To put something back into the array, you need the index. So the first of these three examples is the right way to do it. The other two examples are wrong. So allocate the array, then loop down the array with an index, put something in at each index. Java doesn't exactly have multidimensional arrays. What Java actually has are arrays of arrays. And so if I have a string array, it's really an array containing string arrays. And what that means is that the subarrays don't even have to be the same size. You can have irregular arrays, like this example at the bottom, where I have an array of int arrays, but each int array is of different lengths. That's perfectly legal. So they're not really multidimensional arrays because they don't have to be rectangular or square or whatever. The subarrays can be different sizes. So here's an example where I make subarrays of different sizes. The outer array is of size 10, but the subarrays are of different sizes. And so if I run this, I'll see that I get subarrays of different sizes. That's not done very often. Usually when you have subarrays are all the same size and you have a rectangular array or a square array or whatever. But I want to point out that in Java, there's really no such thing as a multidimensional array. There are arrays of arrays.